Free fall is a constant acceleration motion, and it is caused by the pull of gravity. The acceleration of gravity is a vector quantity which has a magnitude that equals 9.8 meters per second squared, and its direction always points straight down. A common mistake that is always committed by the students when they say that the acceleration of gravity equals negative 9.8 meters per second squared. This is only true if the reference system coordinate that has been chosen has a vertical axis that is chosen to point straight up. When the y-axis is set up to point straight up, and as we know, the gravity always points straight down, therefore, the component of the acceleration of gravity vector is going to be negative 9.8 meters per second squared. On the other hand, when the y-axis of the reference system coordinate is set up to point straight down, and since the acceleration of gravity vector always points straight down, therefore, in this case, the component of the acceleration of gravity is going to be positive 9.8 meters per second squared. In order to clarify the concept of free fall even more, let me ask the following question. Which one of the following three situations can be considered a free fall? Situation number 1, an object is released from rest, where the initial velocity v0 is going to be 0. In the second situation, the object is thrown straight up with the velocity v0. And in the third situation, the object is thrown straight down with the velocity v0. Let's pause and think for a moment about that. Okay, the answer is all of them are free fall motions. In fact, the only difference between them is the initial velocity. The first one has a zero initial velocity. The second one has an initial velocity that is pointing straight up. And the third one has an initial velocity that is pointing straight down. The equations of motion for free fall are exactly the same as those that have been introduced earlier for constant acceleration motion. The slight adjustment can be noticed in the position and the acceleration variables. Notice in the displacement versus time equation that the variable x has changed to y, and the acceleration a is now changed to negative g. The reason for the negative sign is strictly related to the fact that the vertical axis that I have used is pointing straight up, and that's how we are going to handle free fall in this class. The velocity equation is given by v equal v0 plus negative gt. The only adjustment here is done in the acceleration. Instead of a, it's now negative g. The same way we did earlier with the acceleration motion equations, if we eliminate the time from the first two equations, we obtain a third equation which has the following form: v squared equals v0 squared plus 2 times negative g times y minus y0. Notice again that the only change is in the variables of the position and the acceleration. And finally, when we eliminate the acceleration of gravity from the first two equations, we obtain y minus y0 equals 1/2 v plus v0t.